All right, back for the last two. B. A car travelling due west at a speed of 15 metres per second. Let's just put this in. That's a westerly direction, 15 metres per second. Turns due north at a speed of 20 metres per second. Okay. The change occurs in a time interval of, the change in time is 2.5 seconds. Okay, don't need this now, but we will need it later on. First of all, find acceleration. You know, acceleration is change in velocity over change in time, and this question is asking for the average acceleration. So we know that at the end of this problem, we're wanting to be putting numbers into this equation. Delta t we've got. Let's work out delta v. Okay. Delta v equals final velocity minus initial velocity. This is the final velocity. So we call this v. And this is u. Alright, but what we're wanting is negative u. You have to use negative u. So now we can redraw our two vectors according to this formula, and we'll do it in order. This is the way you have to do it. So v minus u. So we're starting with v, and then we put the next one tail to tip, and in the opposite direction. Okay, so this is v. This is now final velocity. This is negative initial velocity. So our resulting vector, we run from the tail to the head, tail of the first to the head of the second, and our resultant vector is this. Now, using the magnitudes, we can work out the magnitudes of these two knowns. We can work out the magnitude of our resultant vector here. C squared equals A squared plus B squared. C squared is equal to 15 squared plus 20 squared. Right, 15 squared plus 20 squared equals 625. Square root both sides, C equals 25. So the magnitude of this vector is 25, and the units meters per second. Cool, right, we've got a magnitude, now we need a direction. So what we want to do is we want to work out the angle in here, right, at the base of this vector. Which direction is it running off in? Okay, so it's a right angled triangle, and we know our opposite and our adjacent angles. So tan theta is opposite over adjacent. Opposite is 15, adjacent is 20. So theta is going to be equal to the inverse of tan, 15 divided by 20. So 15 divided by 20 equals inverse tan. Theta is equal to 36.869, 37 degrees. Okay, so the angle in here is 37 degrees. So our change in velocity is 25 meters per second. North, 37 degrees east. Alright, north, 37 degrees to the east. Yes, that's where you'll find it. Okay, good. Now we can go back up to our original equation here, and we can put in our numbers. 25 meters per second north, 37 degrees east, divided by 2.5 seconds is going to be equal to 25 divided by 2.5 equals 10 meters per second squared. This is acceleration. North, 37 degrees east. That's that one. Okay. Last one. Very similar problem. The next one. A cyclist riding due north at, so this is C, cyclist riding due north at 8 metres per second. Right, this is our initial, 8 metres per second. Turns right to ride due east without changing speed. So that would mean that his final velocity is also 8 metres per second because it didn't change in a time interval of 4 seconds. Alright. So, delta V equals final velocity minus initial velocity. So, final velocity minus initial, so we switch the direction. We do them in order. Final velocity minus initial velocity. And our resultant goes from the tail of the first to the head of the second. This is our resultant vector here. C squared equals A squared plus B squared. Use Pythagoras' theorem to find out the magnitude of it. So we're looking at 8 squared plus 8 squared. So 8 8s are 64. 64 plus 64 is 128. 128 square root. C equals 11.3 metres per second. So this vector is 11.3 metres per second. Fine. Now we need a direction. So let's find out what theta is in here. Okay. Tan theta equals opposite over hypotenuse, opposite over adjacent. So theta is the inverse of tan of 8 over 8. 8 over 8 is 1. Inverse of tan of 1 is 45. So this is 45 degrees in here. So there's a couple of ways we can use this bearing. We can either say that the resultant velocity is 11.3 metres per second, and when we're giving our bearings, we're either going to use north, we're going to use south, so it has to be off this vertical axis. So we could say if this is 45 in here, and this is 90 degrees in here, this has to be 45 in here. So we could say south 45 degrees east. Okay, or it's right in between. We could also say 11.3 metres per second southeast. Either or, both are fine. Now, getting back to what it was asking us for, it was asking us for the average acceleration, delta V over delta T. Delta V is 11.3 metres per second southeast, divided by delta T, which we know is 4 seconds. So we end up 11.3 divided by 4 is 2.8 metres per second squared. This is acceleration, don't forget. Southeast. That's it. So, key things to remember are drawing your vectors in the order that you see them in the equation. So your final minus the initial in that order. Then your resultant vector from the base of the first one to the tip of the second one, and then working out your coordinates and basing them either off north either way or off south either way. Okay. Any questions, you are more than welcome to come and see me, and the next time I'll see you is on Tuesday, and don't forget that I'm happy to stick around all recess on Tuesdays.